Hello everyone, my name is Dmitry. I work as a software engineer in EPAM, and today we will talk about Java annotations. What are Java annotations? Java annotation is a tag or special class that represents the metadata. That means that it attached with a class, interface, method, or field to indicate some additional information which can be used by Java compiler and JVM. And Java annotations in Java are used for providing additional information. So it is an alternative option for XML and Java Maka interfaces. There are several types of annotations which are built as a tree. So in the root we have Java 1 annotation class. Then we have standard annotations and custom annotations. We will describe them in the end of talk. And standard annotations consist of general purpose annotations and meta-annotations. And I will start with general purpose annotations. First one is override annotation, and it indicates that a method is intended to override a method from a super type, from a super class or some interface. And that means that if we mark some method with this annotation, then in a parent class, we should have annotation. We should have method with exactly same name and exactly same arguments. Oh, and here is a source code of this annotation, and these two lines show that this annotation can be used only with a method, and it is recognized by a compiler on compile time. That's it. Next one. Next one is deprecated. There are situations when we want to let clients of our code know that some members of class should not be used anymore. And for this purpose, we use deprecated annotation. For example, in Java 17, some constructors are marked as deprecated, and the same for a file input stream. So method finalize is marked as deprecated. And starting from Java 9, this annotation got two additional attributes, since and for removal. Since means version, starting from which this element is deprecated, and for removal means that in next releases this code will be cut off project. So if we still will be using it, so after upgrade we will get compile error. Next one, suppress warnings. There are situations when compiler gives us warning about our code in case if our code is not clean. Example, private list versions. I haven't specified type of this collection, and in this case, compiler will mark it as mark it and ask me to look at it. And another side, if we have some instruments for code analysis during our build, then this warning can lead to build a failure. In this case, if we are 100% sure what we are doing and we need this construction, we can put suppress warnings, and compiler won't complain anymore on this code. Next one, save var args. Since Java 5, we can pass to method unknown number of arguments. For example, we mark that in this method we pass objects of T type, and 3 does mean that we can pass 1, 2, 3 or more arguments. And this can lead to class cast exception on runtime. So here we have the same construction. We pass several strings and make a method equal to array of the same type, and there won't be any compiler errors here. Here we call this method and make it equal to array of strings. And although there won't be compile errors, at runtime we will have a class cast exception, because obviously we cannot cast several strings to array of strings. And a compiler can only issue a warning on this code. And if we know what we are doing, we can put this annotation, save var args, and compiler will stop complaining. That's it. And the next and the last general purpose annotation is functional interface. Since Java 8, Java, which was originally a pure OOP language, has got some features of functional programming. And if prior to Java 8 we had to create anonymous class for implementing runnable, if we wanted to start a thread, then starting from Java 8 we can use a lambda expression, and it has more short syntax. Here functional interface is a marker for compiler, which method we are implementing with a lambda expression. And a functional interface is an interface with exactly one abstract method. In most cases, we do not need this. We do not need to use this annotation explicitly, because in JDK there are a lot of already implemented functional interfaces for a lot of production cases. Okay, then let's continue further with the meta-annotations. Vlad, please take a word.
Hello, everyone. My name is Vladislav. I'm a software engineer too in EPAM, and we're gonna be talking about some other topic. We already talked about some standard annotations. There's also general purpose annotations, and now we're gonna be talking about meta-annotations. As you can see, there are 5 of them already presented in Java. All of them situated in Java annotation package. And what is a meta-annotation in general? Well, it's basically an annotation that can be used to annotate other annotations. So when you're creating an annotation or when you're specifying something, you can use meta-annotations with other annotations. So here's what I'm talking about. First, let's look at annotation target. So what it does, it actually shows to which element can an annotation can be applied. So it takes an element type enumeration as an argument, and on the left you can actually see the full list of all the arguments you can apply. There is an example on the right picture. For example, we're creating an annotation. It's called custom annotation, and we're setting its target to a method and package. That means that this annotation can only be applied to a method or to a package. So if you, for example, want to make annotation applicable for a field, so you correspondingly make its enumeration element type to field. Same for class, for example, you set it to type, and etc. etc. The next one is retention. So it actually describes for how long should be your annotation, custom annotation should be visible for. So we actually have 3 retention policies in Java: source, class, and runtime. So the first 2 actually you use them if you want your annotation to be visible only when you're writing your code and when you're compiling it. But the main problem is that your annotation won't be visible during the runtime. So it won't be visible while you're running your app. So there's an example on the right. For example, we're creating an annotation. It's called runtime retention, and we're marking its retention policy as runtime. So that means that we can get it through the reflection API of the Java. So during the runtime, let's see an example. I have an example of method get annotation from the reflection API. So for example, we have a class, it's called male, and it's annotated with an annotation human. So to get it, we actually need to pass the method get annotation, and if the human annotation is marked with retention policy runtime, we can actually get it. So as a return of this method will be an actual annotation human. So the next annotation is inherited. That's just an annotation that shows that if we're applying some annotation to a class, every other subclass that extends this class will also be applied to this annotation. So here's what I'm talking about. First of all, there is main usage represented on the right picture, and here's some small example. For example, we're creating an annotation called meta-annotation. We're marking it as inherited. So now, if we are creating a class called superclass, we're marking it with annotation meta-annotation, and we're creating a subclass of it. So we're extending a class superclass. And if now we're, as I said earlier, trying to get with reflection API the number, for example, of annotations, or we're trying to get an annotation, we will actually get my annotation in subclass because this annotation is inherited. So subclass just got this annotation from its superclass. The next annotation is documented. So it's just an annotation that shows that this annotation would be presented in document when you're documented your classes. So for example, you have an annotation, custom annotation, and you're applying it to a class. So if you're not using this annotation, you will see as the presented on the raw picture. So in documents, you will only see the class. But if you're marking it with documented, you will actually see that in documentation, you will have this annotation presented. Okay, and the fixed annotation, it's actually repeatable. Its purpose is simple. It just shows that some annotation we're creating can be applied multiple times. So it also takes class as its argument. So let's see an example. For example, we're creating an annotation, words. It's called words. It's just getting a string as a value, and we're marking it as repeatable. So what we're passing in repeatable, we're actually passing its like super annotation that actually will contain all the annotation, all the repeatable annotations at once in one array. So let's see how we can use it. For example, we have a class speller, and we're marking it like 2 times with annotation words, with word 1 and word 2. So now to get all the annotations we have here, because they are repeatable, there are multiple of them. So we're referring to its super annotation. We're getting it through the reflection API. We're getting the whole array of them in the myRepeatedAnnotations class. So we are returning all 2 of words annotation with word 1 and word 2. To summarize, if we want to create a custom annotation, we should follow 3 simple steps. First of all, we should declare it as a type. So we're using our interface keyword. We're just declaring it. Then, if required, we can set some, for example, type. If we wanted to apply for a method, we just set element type method. For example, we can set it to retention. For example, we can make it inherited, and etc., etc. And of course, we can add some fields for it to be more practical, more usable. Of course, there raises a question where we're talking about meta-annotations. So, of course, we can create meta-annotations in Java, but just a moment for you to think what parameter should we set, what keyword should we use to create a meta-annotation. The answer is pretty simple. We just should set our target to element type or to annotation type. The only difference between them that type covers all the types, for example, class interfaces and annotation interfaces, and annotation type cover only annotation interface, only creation of annotation. So here's a small example. On the left, there are shown the creation of 2 annotations, test and slow test. And both of them, both of their targets are marked as type. That means those annotations can be applied both to a class and to an annotation interface. And here's the implementation. If we look at the 2 right pictures, on the first, they are showed both usage of post annotations on a class, so just as a regular annotation. And on the second picture, we can actually see that those annotations are used as meta annotations. They are used while we're creating a new annotation. So, of course, if we did set the target to an annotation type, not only to type, that means that the first picture of the right won't be reliable. So we cannot apply it to a class, so only to annotation interface. And of course, there are some examples in the real world of custom annotations. For example, we have a popular framework, Spring, for web applications. There we have an auto-wide, for example, annotation. We can mark, for example, fields to show the Spring that a serial bin should be applied to a field, or maybe we can use get mapping on some method to show that this method is using some get requests in it, and etc. And for example, about Lombok library, a very useful library for Java, where developers use it to write a few code. For example, if we have some model, we can also use all arguments constructor in Logbook, because if you have a lot of fields in your class, you need to create a big constructor for them where you like set up all the fields and you initialize them. But you will no need for that anymore because you can mark all your model with all arguments constructor. And now you're just replacing all your constructor with just one line of code, one annotation. So that is very practically useful. So that's basically it. Will be any questions? Like I've already
Thanks
said,
for great presentation.
for example,
yeah, we have one question.
Could
Could
you
you please provide
you
some
on
real examples where custom
annotations
annotations could be useful?
for example, you can use annotations for some repeatable actions. Maybe you, for example, some of the field need to be initialized repeatedly, so many times at once. So you just mark any field that should act like in the same way with this annotation. You only write an annotation and apply it for any field. So now it just like helps you to how to do this, combine your code in once. So it can be useful for you also.
And I want to add another more complex example is custom annotation can be used in aspect-oriented programming. For example, if we have some repeatable code which we want to be executed before any method that we are calling, that we create so-called aspect. We put there our code, which will be which we will call multiple times, and we mark our method with a custom annotation, which will link to our aspect. And the aspect is a class with our code with which will be repeated before every method call. So this approach makes production code more clean and reduces code duplicates.
Thanks. So we don't have any questions, and I think we can end our presentation.